folks, now that we have the idea of an angle well defined, and you can measure an angle in radians or in degrees, I want to talk about the main idea of what trigonometry is based on. And really, trigonometry can be built two different ways. It can be built based on the idea of a unit circle, which is where we're going to start, or the idea of triangles, which we will discuss in a future section. Now, it's not different trigonometry, it's building the same trigonometry, but based on two different ideas that turn into the same idea. But we're going to start with something called the unit circle. So just to even begin the conversation of a unit circle, I need to help you understand the equation of a circle. So what I've got here for you, now you see this, is a straight line, and every straight line has a distance, right? And so if I walk from one point to another point in a straight line, say down a hallway, that's easy to measure because you could just get out a measuring tape and mark where you start and mark where you end and measure that linear measurement. But what if you're talking about a line in the XY axis? And so we could say this is where we begin down here, and I'm going to label that point, let's say X1, Y1, okay? And we end at this point at the top, and I'm going to call that point X2, Y2, okay? How could we measure that? Now, if this were to scale, I guess we could get out our measuring tape and begin it down here at X1, Y1 and end it right here at X2, Y2. But this is not to scale. We just want to know the units to get from there to there. And since it's not completely horizontal and not completely vertical, you can't just do subtraction like, 5 inches minus 2 inches will give us 3 inches. That won't work. So we have to do something here, and the something is to turn this into a triangle. So what I'm going to do is draw a horizontal line here, you see it at the bottom, from X1 all the way to X2, and then a vertical line down here. Now what this does is it creates a right triangle. Now, there's something you know about right triangles. The Pythagorean Theorem applies to right triangles. And in general, if you just have a general triangle, let's just say there's my right triangle, and I call this side A and this side B, and this side over here is special. It's called the hypotenuse because it's across from the 90-degree angle. That's C. Well, the Pythagorean Theorem states that side A squared plus side B squared is equal to side C squared, and I feel confident that you've seen that before. Now, how can we use that to measure the distance from X1 to X2? Well, we have a right triangle. If we knew how long this side was, say it matches A in our picture over here, and how long this side is, which matches B in our drawing over there, then we could find the hypotenuse, which is the distance we're trying to calculate, and again, using the Pythagorean Theorem. Now, do we know how long this line is at the bottom? Well, let's think about it. This point right here, okay, can we label it? Now, you might be thinking, well, I don't know what this scale is, but remember, the scale doesn't matter. I'm calling this point X1, Y1, and this point X2, Y2. Now, if I think about it, this point down here, the X moves over, right? The X is actually the same value as the X straight above it. That point is X2, and the Y value is the same as the Y value to the left, so Y1. So if I were to calculate this distance across the bottom here, it really is just X2 minus X1. Very similar to if I wanted to calculate this distance right here, it's straight up and down. So if I subtract this Y value minus this value, that's Y2 minus Y1. Again, notice there's no Y's involved in this distance because you just take this value and subtract this value. Say this was 5 and this was 2, then it would be a length of 3. But we don't know the x's, so it's just this x minus this x, so x2 minus x1. Same with the y's. Now, if I substitute that into the Pythagorean theorem, watch what happens. Now, this distance here is the one we don't know, right? I'm going to call that d. That's what we're looking for. So if I plug that in my formula, a squared. Now, a was the side along the bottom there. That is x2 minus x1. And I'm supposed to square that length. Plus b squared. Now, b in our picture here corresponds to y2 minus y1 in my picture here. So it's y2 minus y1 squared equals. Now, c represents the hypotenuse. So the hypotenuse in this picture is d, and I have to square it. Now, say I'm supposed to solve for d, right? I'm trying to know how long d is. Not how long d squared is, but how long d is. So what I need to do is take the square root of each side. Now, when you use the square rule as a tool in algebra, you're supposed to write plus or minus. Notice I took the square root of both sides. I should write plus or minus over here. But now, fact is, we're talking about how long a line is, right? So a line can't be, say, -3 units long because you're talking about distance. So in this particular application, the negative doesn't apply. So right now we have the square root of x2 minus x1 squared plus y2 minus y1 squared, and that equals to d. And y'all, what this is, I'm going to highlight it for you, is the distance formula. So notice we haven't mentioned a circle at all yet. We just proved the distance formula. And I have it written up here already. We started with the distance formula, but I wanted you to see where that comes from. And it comes from the Pythagorean Theorem. Just saying this distance is x2 minus x1, we square it. This distance is y2 minus y1, we square it. We plug it in under our square root to solve for d. And there we go. That is the distance formula. Now, what in the world does that have to do with the equation of a circle? Well, I'll tell you. So we have a circle here. Notice the definition. It says a circle is defined to be all points equidistant from a single point. Okay, so we have the single point right here in the middle. We call it C for center. Now, that C is a point, so there's an X and Y that corresponds to that. And we're going to give it a special name. We're going to call the center HK. Okay, why they picked H and K, I do not know. I could probably do research and find out for you, though. Now, if we say a circle is all the points that are the same distant or equidistant from that single point, so this distance clearly is the same as this distance, it's the same as this distance, you get it. It's the same as everywhere, every single point on this circle is the same distance from that center point. Okay? Now, that distance, y'all, we're going to call that R. Why do we call it R? R stands for radius, because the radius is the distance from the center of a circle to any point on the circle. Now you say, what does that have to do with the distance formula? Well, how many times have I said distance already showing you this circle? It has everything to do with the distance formula. So let's calculate this distance right here. Now, we said that a circle, again, for the third time, is any point that is the same distance from this point. So I'm going to call this point out here just any random xy. And where I drew it, wouldn't matter. I could have drawn it here or just anywhere along the circle. I just picked there. Now let's calculate this distance. Now remember the distance formula. Let's write it again at the top from the previous page. Let's just take a gander of that from the previous page at the top here. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. What are x1 and x2 and y1 and y2? They're just points at the beginning and the end of our line. Okay, well, we've already named the points at the beginning and the end of our line. We're calling the one point H and K and the other point X and Y. So again, I'm going to copy the equation. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root. So if I do that for this picture that I have going on, I'm not calling the distance D, I'm calling it R, right? So R is equal to the square root. Now, x2 minus x1 means I'm supposed to subtract my x's. Well, the x here is called h, and the x here is called x. So I'm going to say x minus h squared plus, this says I'm supposed to subtract the y's. y2 minus y1, I left off the square. It really is there. So I subtract my y's. Now, in my picture over here, my y's are called y and k. So I'm going to say y minus k squared, and all that's underneath a square root. Now, this is the equation of a circle with center HK and radius R, but that's not the form you'll usually see. What you usually see is this. You'll see R squared is equal to x minus h squared plus y minus k squared. Now, where in the world did that come from? Well, how about we just, to get rid of this square root, we squared the left, and if you square the left, you must square the right, and there is our equation of a circle. So R always stands for radius, which is the distance from the center of the circle to any point on the circle. H is the x value of the center, k is the y value from the center, and x and y is any point on the circle. So any point that lies on this circle would make this equation true. So the circle equation just comes from the distance formula, and the distance formula just comes from the Pythagorean theorem. And there you are. There's a summary of this information. So once again, our center right here is called HK, and x and y is any random point on the circle. Every one of them would make that true. So this is generic. Again, a reminder, HK is the center of the circle, R is the radius, and XY is a point on the circle. Now, you've heard me keep saying this idea of a unit circle. Well, what the world is a unit circle? Well, let's go to another page. There is a unit circle. Now, what's significant about this particular circle is look at the center of the circle. The center of the circle is right here, 0, 0. So 0, 0 is my HK. So HK equals 0, 0. Okay? Now the radius of my circle, so the distance from the center of the circle to any point on the circle, is 1. And that's why we call it a unit circle, because unit means 1 in math, and our radius is 1. So R is equal to 1. Now if I use my formula, okay, my formula that we just learned is that R squared is equal to x minus h squared plus y minus k squared, and I plug in that information. So R is 1, so I have 1 squared is equal to x minus, again, my h value is 0, right? Hey, so is my k value. Now if I simplify that, we know 1 squared is 1. X minus 0 is x, don't forget it's still squared, plus y minus 0 is y, and that's also still squared. And that gives us the equation of our unit circle. So that's where we start. Now there's a lot more that goes into this unit circle, but that is the unit circle that we're going to be dealing with. Now what we're going to do next, in the next video, we're going to divide this unit circle up using angles. So you remember when we learned about angles in the very first section, an angle in standard position begins along the positive x-axis. So all of our angles are going to begin right here, okay? And then you measure counterclockwise for a positive angle, so that's what we're going to do. And we're going to divide this circle up into some standardized angles. Okay, hope you have a wonderful day.